The last topic we'll take a look at in section 9.1 is how to determine the sample size n needed for a confidence interval for a population proportion. Before collecting a sample for a study, you'll often need to determine what sample size you need in order to achieve the level of precision that you desire for your confidence interval. You'll need to know that sample size in order to be able to plan ahead and to apply for grants. One way to determine the sample size is to use either one of these formulas. There are two different versions. One version is when there is what they call a prior estimate, and the other version of the formula is when there is no prior estimate. We'll take a look at both of these formulas in example 3. Example 3 is similar to section 9.1, number 35 to 40. Suppose that you're a data analyst at First Rock Credit Union and you wish to estimate the percentage of families in Riverside County who plan to purchase a new home this year. You desire that your estimate of P, of this percentage P, to be within 2.5 percentage points and have 98% confidence. The question is, what sample size, in other words, how many families should be obtained in your sample if, and in part A we say if, you use the estimate of a 2018 study that 32% of families in Riverside County plan to purchase a new home that year. In this case, if you are using an estimate from a 2018 study, that means that you're using a prior estimate. There's some other study that came up with a percentage that you can use. And so since there's a prior estimate, you will use this version of the formula. So in this formula, the P hat is the prior estimate, in this case 32%, and so we'll use P hat equal to 0.32. In the problem, it also mentions that you desire your estimate to be within 2.5 percentage points. That statement refers to the margin of error. And in other words, we want the margin of error to be 2.5 percentage points. Converting 2.5% to a decimal would give us E equal to 0.025. So there's the E in the formula. Our P is 0.32. The last thing that we'll need is this Z sub alpha over 2. And to get that, you can use table 5b again. In the problem, it mentions that we would like our interval to have 98% confidence. So going to table 5b, we'll look up 98% confidence. The Z value for that is 2.33. We'll input all of these values for a P hat, for E, and the Z, and it comes out to 1,890.125824. Sample sizes must be whole numbers. In this case, we're talking about the number of families, and it wouldn't make sense to talk about a half a family or 1/3 of a family. So, because sample sizes are whole numbers, it's best to always round up your number to the nearest whole number. So, this is the result that we got, and just to be safe, I'm going to round that up to about 1,891. So, therefore, if we're using a prior estimate for our calculation, you would determine that you need to obtain a random sample of 1,891 families for your study. So here's part B. Let me go back to what it said in the problem. So the question was, what sample size, how many families, should be obtained if you do not use any prior estimates of P. So if you're not using any prior estimate, you're not using any previous study that will give you a P hat, then you'll use this version of the formula. And keep in mind that this 0.25 is just part of the formula. It's always going to be used in this formula. So all that we'll need for this is to find E and the Z. And we already know what those are. So as was mentioned a few minutes ago, the margin of error, the desired margin of error is 2.5 percentage points. That means that E is 0.025. To find the Z, we just look up the Z for 98% confidence. Look that up in table 5B, it's 2.33. Input those values into this version of the formula, and it comes out to 2,171.56. And again, since sample sizes are whole numbers, then it would make sense to go ahead and just round that up to the nearest whole number. So that rounds up to about 2,172. So in other words, if you're using no prior estimate in your calculations, then you would determine that you would need to obtain a sample of 2,172 families for your study. So before concluding this section, there are a few reminders that I think are good to go over. So one is that confidence intervals allow scientists to make an inference or an estimate about a population parameter based on the results obtained from a random sample. So keep that in mind. This is just an overview of what they are and how they're used. Another takeaway is that you can calculate confidence intervals by using either one of the methods that we covered, either on the Casio or the TI calculator or using a formula. And the last takeaway is that it will be important to understand how to interpret confidence intervals and also understand how they inform hypotheses. That will come up in the homework and on quizzes and tests, so you want to make sure to be comfortable with just understanding the meaning of confidence intervals. And that concludes our lesson on section 9.1.